Hello and welcome to the new video, and in this video we are going to make an Einstein tile which makes a non-repeating pattern. So it was discovered by this guy Dave Smith. So I'm just wanted to make a parametric Einstein tile. So before we start making the tile, so let's have a look at the tile. So this is the shape of the tile. Alright, so how it is made out of 3 hexagons like this. So it has 3 different kinds of lengths, and the 3 lengths here are shown. The one is the biggest side, which is the side of the hexagon, and that we will be using as a basis to calculate all other lengths. So if this is my side S, so this blue color or the cyan color is going to be the half of this side length. And obviously this can be easily calculated also as a function of this. And for me to start doing this pattern or this drawing inside Revit, I just want to make use of this center, where all 3 hexagons meet as the starting point, which is this. And now here finally this S is a hexagonal side length, and A obviously, which is the cyan, it's half of the S, and B we can easily calculate. This becomes the sine 60 times the side of the hexagon. So now we quickly jump to the Revit, and it's just a sample project. And now I'm going to make use of new family template, and I'm going to choose metric generic face-based model. Alright, so because we have to attach, or we have to make use of some certain face so that we can attach our tile to either a vertical or a horizontal slab or whatsoever. So I'm going to quickly make 3 or 4 parameters. So first of all, I'll call side and let it be type parameter for the time being. Let's say I start with 100, and then I can call A, and then B, and then obviously there will be some thickness. So I'll make a new parameter called thickness. So for the A, it has to be 0.5 times side, and for B it's so before you make a B, so I just want to make the units. So because it's sine of 60, so sine 60 is 0.866, then I'll have to increase the decimal places to at least 2 to get more accuracy on the drawing. So now when I'll go here and I'll say side into sine of 60, and then thickness, I'll keep thickness of, let's say, 35. Alright, so I can just start doing it. Now the thing is that to easily calculate this, if I look at this, so if I start from this point, so this is half of S, which is A, and then another A. So what I need to do, I need to create 2 A's on the right and 3 A's. If you calculate this is also going to be A, and then 2 more A's. So what I'm going to do is that I'm going to make a reference plane. I'm going to make 2 reference planes on the right and 3 reference plane on the left, like so. And then I just have to do this. I'll make this A, and then another one, and I'll select this also A, and here again 2 and 3. I can select them one by one or all at once to make them all A. And then if I go back to my image, so I need 1 reference line here, which is this side is equals to this side. Obviously you can it makes sense from the center of the hexagon to this is same as from here to this center point. So it's going to be B, and likewise here at the bottom. So what I'm going to do is that I'm going to make another reference plane like so, and one at the bottom, and that's it. And then this is going to be B, and also this is going to be B. And now I can actually start making my, so just to make sure that I don't drag those. So this one is my center from where my modeling will start, from this center. So at this center I have, first of all, this, so I can come down. All right, I can go down because there will be no line here. So what I'm going to do, I'm going to start an extrusion, and here is I can come down from here to here. So as you must notice, because this is B, so I have to make use of align AL. I can align my endpoints, and I can align the line itself with the reference plane. So I have made this line, and the next is that I have to make 120 degree with another dimension of B. So I make a line like so. I can just drop the endpoint anywhere, and then I just make use of this angular dimension and unselect the line and adjust it to 120 degree, select the dimension and lock it to 120 degree, and then and then I just if I select this line, this temporary dimension appears, so I can just make it permanent and move it a little bit below, and I have to select B. So that makes me this line, and now I have to, so now this angle is 90 degrees. All right, so what I can do is that make a line like that and go 90 degree. So it's 90 degree, and I can just simply, so the thing is that I think it's going to come here, and if you can see, it's exactly 50, which is the which is A. So because it's at the intersection of two reference planes, so I might not need to do anything here, and you'll come to know in a while. So the next thing is that I have this another line, so I'll make another line here like so. So for this line, what I can do, if I just align this with endpoint, and this one with this endpoint, and this reference plane with this line, then all the necessary alignment for this line is automatically done. You don't need to do anything. So next I have to go up again, which will bring me back to here, because this length and this length is going to be same. So what I will do is that I will just make a line and go here. It's already aligned with this reference plane. All I need to do is to align with this reference plane, this endpoint, and that's it. And now I have to go here 120 degrees. So I'll be going like so. I'll just make the line anywhere, and I can select this angle as 120 degree this time instead of this external. I just drop anywhere and I select the line and I make it 120 degree, select the angle dimension and lock it again so that it doesn't change the value. And the next thing is that I have to select this line, and again I will make this temporary dimension permanent, and I'll move it down, and then I'll choose this B. All right, and now I have to go this way with 90 degrees. So what I'll be doing is go like that, 90 degrees. At the 90 degrees, the line before that, it starts. So you see it's again going to meet this reference plane. Okay, so again I don't need to do anything here because it's because of its intersection with two reference planes. And then I have this one line from here all the way here, which is actually my total S side length of the hexagon. All right, so I'll be making a line with this reference with this point, this reference plane with this point, and this reference plane with this line. So nothing else I need to do. Now I need to make a line with a dimension and 180 to 120 degrees. So I'll be doing like this, and I drop it anywhere, no problem. I can set the angle later. So this is 125. Select the line, make it 120 degrees, select the angle dimension and lock it, and make this temporary dimension as permanent. Move it little back and make it A. All right. Next is that I have another 190-degree line, and this time these two lines are both going to be B. So this is going to trouble me, so I'm just going to hide it. Not a problem. I'm making a line and with another 90 degrees. So if you notice here, this 86.6, which is B, and is going to meet the intersection of these two. So I'll just do this without doing anything, because later on I will have, so what I can do is I can align this with this and this with this. So in this way I don't have to select this and make this permanent, because in any way whenever the value of site S changes, everything will grow automatically, and these two reference planes, they need to meet this line, so I didn't need to label this. So next is I have another one of this line which is at again 120 degrees, so I'll just make like that. I just make the angle dimension, select the line, change the angle value 120 degree, and select the angle, lock it, make this dimension as permanent like so, move it little back and select this to be B. This is my B. And next thing is this 90 degrees. So with this 90 degrees like this, it's going to coincide with this. So and again I don't need to do anything because of the intersection. And again, so if anything is, nothing is missed out, because even if I try to lock this line, it will not allow me, because it's already aligned because of the constraints given below here. So now I can reset, and this total tile is ready. Now the thing is, the last thing, I can end my extrusion at the thickness, and that's it. And here is my Einstein tile. So that's it. Now what I can do is that I can just quickly change the material, and I can just do duplicate, and I can call it tile. I can let's say I call it tile green, and I just select the color, some green color, hit OK, and that's it. I can load it in my project, and now I can put it on vertical face or even the horizontal face. So this is my tile. Now I can start playing with this actually. I can start doing the tiling. So it is completely parametric. So I can change, if I go back to my family, so this is my family. If I change my side length, let's say I can change it to 145, so this is perfect. It's just grows. I can make any size. I can decrease the size, let's say 80. All right, so this is everything is fine, it's working. All right, so now I can start doing tiling and have fun with this. It's completely parametric. I can change values here. Let's say I make it 180. I can change the thickness to 60, and I can do the tiling. Thanks for watching. Have a nice time.